Hey everyone, welcome back to another math lesson. Today we're going to continue on with our quadratic equations unit, lesson number 2, solving quadratic equations by factoring. So let's get started. A quadratic equation is any equation which can be written in the form ax squared plus bx plus c equal to 0, where a can't be 0 and a, b, c, so all the coefficients are constants. Okay? The equation ax squared minus 5x minus 45 equals to 0 contains a quadratic or second degree term. That is, a term with a variable that is squared and no term of higher degree. This is an example of a quadratic equation. Okay, so again, everything that you've dealt with before, where it was just, ax squared plus bx plus c, okay, that was just an expression. Okay, so that's a quadratic expression. Expressions don't equal 0. Okay, as soon as you throw in the equal sign, equation, okay, it equals something. So equation, okay, equation makes sure that it's equal to something, whereas an expression is just stating it. Okay. The graph of a quadratic equation is called a parabola. So methods to solving a quadratic equation: 1, factor; step 2, square root the principal; 3, completing the square; 4, the quadratic formula; and 5 is graphing. So when an equation contains both linear and quadratic terms, it cannot be solved by isolating the variable. One strategy is to solve by factoring and applying the zero product property. Okay, so I'm going to highlight the zero product property. What is that? Okay, so the zero product property, if the product of two numbers is 0, then one or both of the numbers must be equal to 0. Okay, I'm going to highlight that. It's important for us to know. That is, if a times b is equal to 0, then that means a is equal to 0, or b is equal to 0, or a and b are both equal to 0. This can also be applied to binomial factors. So given x plus b, okay, in brackets multiplied by x plus d is equal to 0, that means that x plus b must be equal to 0 and or x plus d must be equal to 0. Okay, so that's either one can be equal to 0. The solutions to a quadratic equation are called roots of the equation. You can find the roots of a quadratic equation by determining the x-intercepts of the graph or the zeros of the corresponding quadratic function. So that's the roots of the equation, the x-intercepts of the graph, or zeros of the quadratic function. Okay, they will all be equivalent to each other, but each one represents something different. Roots is to the equation, intercepts is to the graph, zeros is to the function. Okay, and we're going to go through a couple of examples and determining what each of these can be. So there are different types of solutions. There's 2 solutions, 1 solution, or 0 solutions. Okay, so I'm just going to draw just a quick little graph of it. So again, a parabola kind of looks like a U shape. It's a U shape, okay? So when it's 2 solutions, that means that the graph will pass through the x-intercept twice. Okay? So again, this can be opening up or opening down. It really doesn't matter, okay? But I'm just showing you that this is an example of where there is 2 possible solutions. Whereas the one possible solution means it only touches the x-axis in one possible place. I'm going to say it's going to touch it this place here. Okay? So that's one solution. Whereas no solutions means it does not cross the x-axis anywhere. So it can be something like this. Okay, so those are all different types of solutions that you could have for quadratic equations. He points to solving quadratic equations by factoring. So it is important to know the difference between factoring and solving. Okay, we can factor an equation or an expression. We can only solve an equation, which has an equal sign, but cannot solve an expression. Okay, so factoring, you can factor an equation or an expression, but you can only solve an equation with an equal sign. Okay, also, you cannot solve an expression. It doesn't have an equal sign. You can only factor it, okay? The equation must be equal to 0 for the zero product property to apply. Important for us to know. And make sure all solutions are logical. For example, in word problems, length can't be negative. Okay, it just doesn't make any sense. All right. So what we're going to do now is we're going to go through different types of examples. Let's start with example number 1, solve by factoring. Solve each equation, then verify the solution. Okay, so we have x squared minus x minus 56. So again, what it needs to add, okay, to be equal to -1, but multiply to be equal to -56. So what are the factors of that? Well, that's going to be -8 and +7. Since the a value is 1, we can then separate it to x minus 8 and x plus 7. Okay, so that we have now factored it. We haven't solved it because now we need to solve to when x is equal to 0. So we have x minus 8 is equal to 0 or x plus 7 is equal to 0. So that means if you were to just isolate x, that means that x is equal to 8 or x must be -7. Okay, now we're going to check and see if this is true. All right, so what we're going to do is we're going to substitute the x equals 8 and the x equals -7 back into the original equation. Okay, it's always good to go back to the original equation given to us at the beginning. Just in case we mess something up with our factoring, it's best to go back to the beginning and say, okay, if this works, we should get the similar answer. Okay, so to check, okay, we're going to use x squared minus x minus 56 is equal to 0. And to start off, we will say let x equal 8. Okay, so we will substitute the 8 in. So this is now 8 squared minus 8 minus 56 is equal to 0. 8 squared is 64 minus, well, we can do the -8 minus 56. Okay, that should be 64. And look at that. We have 0 equal to 0, so that's good. Another let statement, so let x equal -7. Again, substitute the -7 in, so we have -7 squared minus -7 minus 56 is equal to 0. Okay, we have -7 squared, so that's 49. And then in this one, we have so a negative times a negative. That gives you +7. Okay, so we have +7 minus 56. That should give us the -49. And look at that, 0 equals 0. That's good. So our answers are x is equal to 8 and x is equal to -7. Moving on to B, we need to make sure that this equation here, so 3x plus 1 multiplied by x minus 6 is equal to 22. In order for us to use the zero property rule, okay, we need to make sure that this equation equals 0. So what we are going to do is we're going to expand these brackets and then move the 22 over. Okay, so we're going to expand the brackets like so. So that means we should get 3x squared minus 18x plus x minus 6 is equal to 22. We'll combine like terms, and we can move the 22 over at the same time. So I'm just going to move the 22 over. Okay. So we have 3x squared, -18x plus x. Well, that's -17x. And then we have -6 subtract 22. That should be -28 is equal to 0. So this is what we want for our zero property rule to take effect. Okay. Now what we'll do is we will factor. When you factor this out, well, this is going to be 3x squared minus 21x plus 4x minus 28 is equal to 0. We factor the first two terms, so that's going to be 3x, x minus 7. And then what's common between the next two is a +4, and then it's x minus 7. Okay, so in this one, it's going to be 3x plus 4, and then x minus 7 is equal to 0. Okay, so that, again, all we have done is just factored it, okay? We need to now solve for it. So that means that 3x plus 4 is equal to 0, or x minus 7 is equal to 0. You isolate for x in each separate part, and then that should be your answer. So then we have 3x is equal to -4, which means that x is equal to -4 over 3. or x is 7. Moving on to C. We have 3x squared plus 75 is equal to negative 30. So same idea. We want to make sure that this entire equation is equal to 0. So let's add 30x to both sides. Okay. So adding 30x to both sides, we get 3x squared plus 30x plus 75. Okay, that's all equal to 0. Now, each of these have a greatest common factor. So before we even start to factor, right, using decomposition, let's factor out the greatest common factor first. And that's going to be 3. Okay, so let's go 3. And now we have x squared plus 10x plus 25 is equal to 0. Now this we can factor. It adds to give you 10, but multiplies to give you 25. And the factors of that is 5 and 5. Okay, so that means that this is going to be 3x plus 5, x plus 5 is equal to 0. That means that to solve for this, that means because they are the same, we can just solve for one of them to say, okay, well, that means that x plus 5 is equal to 0, which means that x is equal to negative 5. To verify it's true, substitute it back in and see what you get. But again, because they are the same, you only need to do it once. Moving on to D. 5x squared equals negative 20x. Same idea. We need to move everything to the other side and then factor. So we have 5x squared plus 20x, and that is equal to 0. We now can factor out the greatest common factor between these two, which is going to be 5x. And then what's left is x plus 4. Now, we still have those two terms. So either one, 5x, or the x plus 4 is equal to 0. So we'll solve for both. So that means that 5x is equal to 0, or the x plus 4 is equal to 0. Which means that in the first case, x is equal to 0, and in the second case, x is negative 4. Again, what you can do is you can go back and you can verify it, see if these answers are true. Make sure you substitute these numbers back into the original equation. Okay, moving on to example 3. Example 3, word problems with quadratic equations. So we're going to write a quadratic equation with roots that are 4 and negative 2 over 3. So a big thing to take away from this is the word roots. Okay, and roots are telling us that this is going to be x is equal to something. Okay, that's what we are going to find out. That's what we are going to try and figure out. Okay, let's get started. All right, we have to create this equation. So the roots is x is equal to 4 and x is equal to negative 2/3. Okay, so a quadratic equation. So again, this has to equal something. Okay, so this must have an equal sign. All right. So that means that x must equal 4 and x must equal negative 2 over 3. Well, if that's the case, this is kind of working backwards. So if x is equal to that, that means that x minus 4 must be equal to 0, and x plus 2 over 3 must be equal to 0. Fair? Now, if that's the case, we can then multiply them together, because it still holds true that x minus 4 is equal to 0 and x plus 2 over 3 is equal to 0. So we can say that x minus 4 multiplied by, right, x plus 2 over 3 is equal to 0. Now we can expand the brackets. Or, before we do that, do we even need to do that? Have we satisfied the question? Have we answered it? Write a quadratic equation. Must have an equal sign. Well, I see an equal sign. There's one right there. With the roots of 4 and negative 2 over 3. And here are the roots, 4 and negative 2 over 3. And here they are represented in each bracket. So technically, we actually don't have to expand them. What I would like you to do is expand out the brackets. See what you get. Moving on to B. The sum of a number and its square is 20, and we are going to determine that number. Okay, so the sum of a number and its square is 20. So we can say that the sum of a number, well, we don't know what the number is technically, so let's call it x, because that's a number. Sum means you're going to add, okay? So the sum of a number and its square. That means the x must be the same number, and its square must be 20, okay? So from there, the sum is your addition of a number, okay, and then its square must be 20. Each part of the question is now satisfied in our equation. Now we need to solve. Okay, so let's go ahead and let's do that. X squared plus x minus 20 is equal to 0. We had to move the 20 over so that it satisfies the zero product rule. Okay, so we now say what adds to equal 1 but multiplies to equal negative 20. And that's going to be negative 4 and positive 5. Okay, so now we can split this apart to be x plus 5 and x minus 4 is equal to 0, which means that x plus 5 is equal to 0, or x minus 4 is equal to 0, which means that x is negative 5, or x is equal to 4. So there's two possible answers for this question. And what I'd like you to do is verify to see if it's true. Moving on to C, a rectangle garden has dimensions of 5 meters and 7 meters. When both dimensions are increased by the same length, the area of the garden increases by 45 square meters. Determine the dimensions of the larger garden. Okay, so if this is our garden, and it's 7 meters by 5 meters, okay, when both dimensions are increased by the same length, that means we added x to both of them. Okay, and the area of the garden increases by 45 square meters. But before we get into any of that, let's calculate the original area. So the original area, okay, so area equals length times width, which means that it's equal to 7 times 5, which means it's 35 square meters. That's the original area, okay? But now the area of the garden has increased by 45 square meters. So that means because of this garden increased by 45 square meters, our 35 is now increased by 45, which means that it's 80 is the new one. Okay, so let's calculate the new area. So here's the new area. So we have area is equal to length times width. Okay, the area of the new spot is going to be 80. Well, that's going to be equal to 5 plus x and 7 plus x. Because we need to find what the dimensions are. Okay, so what we're going to do is we're going to expand these brackets and then move the 80 over so that it equals to 0. Okay, so let's expand the brackets first. So we get x squared plus 5x plus 7x plus 35. Okay, combine like terms and move everything over. So that's going to be 80 is equal to x squared plus 12x plus 35. And what we're going to do now is move this 80 over. Okay, so that's going to be x squared plus 12x minus, right? So it's going to be minus 45. And that is now equal to 0. So now what we need to do is factor and solve. So what adds to give you 12, but multiplies to give you negative 45. That's going to be 15 and negative 3. Okay? So that means that x plus 15, all right, and then x minus 3 is equal to 0. That means that x plus 15 equals 0, or x minus 3 is equal to 0. Well, that means that x is equal to negative 15 or x is equal to 3. However, one of them won't work. And that's going to be negative 15. The reason being, okay, so we're just going to say that this one doesn't work. You can't have a negative length, right? If we were to say that that x is negative 15, that's going to cancel everything out in our original garden, which means that the garden would no longer exist. But that's not true because the garden increased by 45 square meters. That means that our answer has to be 3. So the dimensions, right, determine the dimensions of the larger garden. That means that it's 5 plus 3, which equals 8 meters, and 7 plus 3, which equals 10 meters. That is the new dimensions. Your length and your width. Done. Those are your new dimensions. Last example. We're going to solve this equation, then verify the solution, and we have a radical that's in this one. Okay, so radical is square root. All right, so let's figure out how we're going to solve this. But what we're going to do is we're going to move everything over to the one side. We're going to move everything that's not under the square root to the right side. We're going to move the 4. Now we have the root of 6 minus x is equal to x minus 4. Okay. Now what we're going to do is to get rid of the square root, we are going to square both sides. Make sure that everything is in brackets, okay? So this one is going to be 6 minus x is equal to, well, x minus 4 squared. Well, that's going to be x minus 4 times x minus 4. Okay, so it's going to be 6 minus x is equal to x squared minus 4x plus 16. 6 minus x is equal to x squared minus 8x plus 16. We're going to move everything from this side over. So we're going to add x both sides and subtract 6. So we're going to have x squared minus 7x plus 10 is equal to 0. Okay. Next is we'll do the add and multiplying. So what adds to give you negative 7, but multiplies to give you positive 10? Well, in that case, it's going to be negative 5 and negative 2. So that means that this splits up. I'm just going to go here. That means that this is going to split into x minus 5 and x minus 2. Okay, and that's all equal to 0. Solve to make sure it works. So that means we have x minus 5 is equal to 0, or x minus 2 is equal to 0. That means that x equals 5, or x equals 2. What we need to do now is we need to verify to see if this is true. So you need to check, right? It says verify the solution. So we need to check. So let's check. Let's do 5 first. Okay, so let's say let x equal 5. Well, if x equals 5, that means the root of 6 minus 5 plus 4 is equal to 5. Okay, well, 6 minus 5 is 1, so we want the root of 1 plus 4 is equal to 5. The square root of 1 is 1, so it's 1 plus 4 is equal to 5, which means that 5 is equal to 5. Good. That's good. That's what we want. So that one's good. Next one. Let x equal 2. Let's see if this one works. So that's going to be the root of 6 minus 2 plus 4 is equal to 2. 6 minus 2 is 4. So it's going to be the root of 4 plus 4 is equal to 2. So the square root of 4 is 2 plus 4 is equal to 2. Well, wait a minute. 2 plus 4 actually does not equal 2. So we can say that this 6 does not equal 2. which means that this one doesn't work. So only x equals 5 works. So there is only one possible solution to this case, and it's that x is equal to 5. Okay? So the answer, and our only answer, is x is equal to 5. Okay? Make sure you always go back and check to see if it's true or not. Okay? Especially when it comes to a radical equation. In this one, when you have a root. Okay? So always go back to check to make sure that both answers, or maybe none of the answers, are correct. Well, that is it for today's lesson on solving quadratic equations by factoring. I hope you enjoyed it, and I hope you learned something. Okay? Remember, when it always comes to math, keep calm and show your work.